quantum ground state. Quantum ground state, that means a quantum system is existing at its minimum energy level. You know, quantum systems means the system, there may be atoms, there may be molecules. Okay, so you know the definition of quantum system. And the electrons in the quantum system, they will also occupy the minimum energy level. And they must follow the Pauli's exclusion principle, according to which multiple electrons cannot simultaneously occupy the same quantum state. So this happens in the quantum state, quantum ground state. Ground state means the state at which energy of the system is minimum. And understanding this quantum ground state means what? Understanding the quantum ground state means the properties and the behavior of the particles or the quantum particles at ground state is required to know. It's very crucial to require to know for the development of new technologies. Yes, there is a chance that new technologies can be developed by knowing the properties and behavior of the quantum particles at the quantum ground state. So, what are the properties which are known? First, I have already mentioned that Pauli's exclusion principle must be followed by the electrons. No two electrons or multiple electrons cannot occupy the same quantum state simultaneously. Again, there is, in quantum mechanics, you know that Schrödinger's equation is there. Again, the science of quantum dynamics is there. Quantum dynamics or quantum mechanics or quantum physics, okay, all are same. So, starts with Schrödinger's equation, which was developed in 1926 by Erwin Schrödinger. You know that thing. What is the use of that Schrödinger's equation? You know, the particles' behavior are governed by using that mathematical equation. Means particles' behavior can be known by using that mathematical equation. That mathematical equation means here Schrödinger's equation. Okay, that is a mathematical equation and use of that thing is known to you. Again, there is Heisenberg's uncertainty principle. That thing also must be maintained at the ground state also. So, what is the expectation? Expectation is, if you know the concept like quantum time crystals. Okay, so in the absence of such phenomena, like quantum time crystals, what is expectation for the ground state of a quantum system? Expectation is there should not be any motion or the oscillations of the quantum system. Yes, there is a chance of fluctuations because due to the presence of Heisenberg's uncertainty principle. That must be followed by a quantum system, by any quantum system. Okay, and since Heisenberg's uncertainty principle must be maintained, so there is a chance of fluctuations of the properties or the behavior of the particles of quantum system. Though those, because here the uncertainties or the fluctuations manifest themselves as the temporal variations in properties or behavior of the quantum particles, but those are not comparable with the motion or oscillations of the quantum system. Okay, here motions and oscillations, motions or oscillations, those are observed only in case of time crystals, the concept like quantum time crystals, where the time itself behaves, means time itself, you will notice strange behavior of time itself in case of quantum time crystals. Anyway, so importance of knowing the properties and behavior of quantum particles at the quantum ground state is, first of all, it is intriguing, and second is we will be able to develop new technologies which may be useful for quantum computing, for material science, for many other things. Yes, research is going on in this field. It is still not fully known by the physicists. The quantum ground state, this is still not fully known by the physicists. So research is going on. Anyway, so this was all about quantum ground state. And one more thing I want to add to this. When the quantum system exists, when the quantum system is existing at the ground state, that means there is the system is stable. That's why in the thumbnail you have seen from Schrödinger to stability. Okay, the system becomes stable. Once again, I want to mention the same thing, that there is a chance of fluctuation. Fluctuations can be noticed, but those fluctuations are not comparable with the oscillations or motion of the overall system, overall quantum system. Anyway, so this was all about the discussion on quantum ground state. Okay, so this is the end of this video. Thank you for watching this video.